even more on total accumulation and net change and average value. This is AB video 4.4F part 2. Okay, so just for review, mean value theorem for integrals, the integral from a to b of f of x dx, remember that's the area bounded by f of x, the x-axis, x equals a and x equals b, is equal to b minus a, which is the width of the rectangle times the height of the rectangle f of c. Average value, therefore, of f of x on the interval from a to b is the integral from a to b of f of x dx over b minus a. So the difference here compared to total accumulation net change is you're not going to integrate the derivative of the thing. For average value, you're actually integrating the thing. So if it asks for the average velocity, you're actually going to integrate the velocity, not the derivative of it. If they ask for the average acceleration, you're going to integrate the acceleration. Okay? So these are average values, which means you're going to have the integral from 0 to 10 over 10 minus 0. Sorry, I don't know why that says a. That should say 0. Okay, in this case. If it asks for average speed, keep in mind that speed is the absolute value of the velocity. So this is the one case where you'll have an absolute value. And again, if you had to do this by hand, you'd have to factor it, blah, 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 like we showed in the other example. And you'd have to split it up from 2 to 3 and 3 to 7 because it's negative on the left side of 3 and the velocity is positive on the right side of 7, on the right side of 3. Okay, so for the last few accumulation problems, and I've given you quite a few, I've posted a worksheet 4.4, so I want you to look at, here's the worksheet 4.4. Just kind of glancing over this worksheet, notice I'm going to point out that what the key thing here, here they're asking for total distance. So remember, for total distance, you'll take the integral of the absolute value of the velocity. Same thing here, what's the total distance? How far does it move between times t1 and t2? That's total distance. How many feet does the particle move? Again, total distance. This is an average velocity, so average value of the velocity, which means you'll be integrating the velocity. Again, average velocity, you'll integrate the velocity. Here you'll integrate the acceleration. Find the distance traveled, that's total distance. How far is the total distance? Total distance, displacement, which is your net change as opposed to total distance. They want both here. Here they want displacement again and total distance. Here they just want total distance, etc., etc. So these are kind of mixed in. There'll be some total, here's total accumulation. Find the total number of gallons of oil that will have leaked, kind of similar to the one we just looked at. How much will the animal population increase? So that's the total increase in animal population. Find the total distance again, etc. Okay, so we're going to look right now at numbers 28. So if you look at number 28, a stone is thrown upward from the ground with an initial velocity of 96 feet per second. Its average velocity is, given that AT during the first 2 seconds is. So they're asking for average velocity, okay? So if you're asked for average velocity, you start with the acceleration. You integrate the acceleration to get the velocity, or you could use our formula that we have. Hang on. Did I not answer this question properly? Did it ask for average velocity? And I did not find average velocity. Let me fix that. Okay, so once you have your velocity function, then the average value in the first 2 seconds would be from t equals 0 to t equals 2 of your velocity, because it's average value of the velocity, so you'll actually integrate the velocity. And don't forget, it's an average, which kind of makes sense that it'd be a fraction, over 2 minus 0. And then, of course, you integrate and then evaluate, etc., etc. Okay, the next one is number 30. Number 30, a rumor spreads through a town at the rate of t squared plus 10t new people per day. Notice it's a rate, okay? They say the word rate, people per day. This is a derivative. Approximately how many people hear the rumor during the second week after it was first heard? So how many people is the total accumulation of people? And during the second week, the first week would be from, and of course, they're mean. Here's per day, and that's per week. Okay, so let's have a look at this one. Okay, so for number 30, the total accumulation for the second week would be from day 8 to day 14. Day 1 to day 7 would be week 1. Day 8 to day 14 would be week 2. It's a total accumulation, so you'll need to take the absolute value, and you'll need to take the rate of change, which is what they gave you, t squared plus 10t, or 1 point, I don't know, what was it? Plus 10t. I don't know what that point is, but it's not there. Ignore the point. Okay. And then you'll just evaluate that on your calculator. Number 32, let's have a look at that. Whoops. How long will it take to release 9 tons of pollutant if the rate at which pollutant is being released is T times e to the negative 0.3 T tons per week? So this is your rate of change. There's the word rate, tons per week. Now, this is kind of a different question. Usually they ask for how many tons will be released. They're actually telling you how many tons are being released, and they're asking you how long it's going to take. So they're asking you basically for that upper limit of integration. So here's what we have. Okay, so the total accumulation, which is 9 tons, is going to be the integral of the absolute value of the rate of change. This is what they gave you from the beginning of time, t equals 0, and that's the thing we're looking for. Till what time? How long is it going to take? So you now have this equation. You can actually solve that equation directly on the calculator. Remember, we're trying to solve for x, which is how long it will take, and you'll get the answer that way. Okay, this is the last question from 4.4. This is an AP question, and this represents the x-axis, or the horizontal axis represents hours, the time in hours, and the vertical represents the barrels per hour. I think this is a barrels leaking, how many barrels per hour are leaking out of a ship of oil. Okay, so we have the Valdez. All right, so Exxon Valdez. So what we have here, as you can tell, since this is hours and they give you 24, so that represents 1 day. So they're giving you this graph, okay, and you can see the sizes, and they give you a grid, so you can see the size. This is 6 hours. This is 100 barrels per hour. Remember, the area underneath in that rectangle, if you multiply hours by barrels per hour, you will get the number of barrels. So for example, here 6 hours times 10 barrels per hour will give you 600 barrels that will leak out in that first 6 hours. Okay? All right, so what you need to do is basically count up the boxes. That's all you're doing. So here, just to give you, you know, how we're dealing with total accumulation, the number of barrels is the integral of the absolute value of the rate of change, which is the barrels per hour, from 0 to 24. Now, that rate of change is your FFT. This is your graph of barrels per hour, which is your rate of change. Okay, and of course, barrels per hours times hours gives barrels. So if you count it up, so these are your options. It's a multiple choice question. So basically, you're going to count up the area of the shaded region, which is approximately 5 boxes. Here's 4 of them, more or less, complete, and these 2 halves make 5 boxes. And of course, remember the hours. Each box is 6 hours by 100 barrels per hour. So the closest one is 3,000.